Hello everyone. So previously we had successfully designed a form validator utility, right? So today what we'll be doing, we are asked to design search indexer, right? So let's see what the question states here. Design a search indexer system that stores multiple text documents, yeah, that stores multiple text documents and allows efficient keyword-based searching by building an inverted index, mapping each word to the list of the document IDs containing it. Inverted index in the sense mapping each word to the list of document IDs containing it. Yeah, the system should entirely the system should work entirely in memory without any external databases, right? So we don't have to worry about the database part. So the system should entirely work in memory without any external database. We will be going with a single file CLI demo, right? So we don't have to worry about the databases. We can just discuss about the databases for now. For to design the problem and to execute, we don't have to worry about any external database. Yep. So this is the question actually. Let's do one thing. Let's collect the functional as well as the non-functional requirements quickly. Yeah. So let's go with the functional requirements. The first requirement is the system should index a set of text documents. Yeah, so this is fine. I believe the system should index a set of text documents. The second requirement here is it should tokenize words. This is fine, and build an inverted index. Yeah, so see here, word to the list of document IDs. Yep, so this is fine. The system should allow fast search. For the documents containing a given keyword. So this is also one of the requirement. The final functional requirement is it should support displaying the ranked results. It should support displaying ranked results based on the word frequency. Based on what? Based on word frequency. Yep. So these are some of the functional requirements. Let's move on with the non-functional requirements. It must be lightweight and also run without any database. It must be lightweighted. Yep. So this is fine. It should execute in memory. Yeah, so this is fine as well. It must have fast lookup time, right? So because one average for searches using the dict. Yep, so this is also fine. The final one, code should be easily extensible and readable. Yep, so these are some of the non-functional requirements. Now, based on the question and based on the requirements that we have collected, we have I have designed this one. Sorry, I have went with a algorithm choice. Let's discuss the algorithm choice here. So I found the inverted index approach to be the best one actually, right? So the algorithm that we'll be going with here is inverted index approach, right? So each unique word is mapped to the list of document IDs. Each unique word is mapped to the list of document IDs. We are discussing about this one approach actually. Yep. Inverted index approach. Each unique word is mapped to the list of document IDs. And this one, the second point here is searching becomes efficient because lookups are big of one using Python dic actually dictionary, right? Searching becomes efficient because lookups are big of one using the Python's dic, right? So the final one here would be tokenization and the normalization ensure consistent and matching, right? Consistency and matching actually. Yep. So example you can just see accordingly, right? So doc one we have mapped to this one. Cat sat on mat. Doc 2 we have mapped this one to the doc sat on log, and the inverted index would become like this. Cat we will be going with 1, sat the next word actually index 1 2, dog we will be going with a 2, and so on, right? And so on. Yep, so this is fine. This is a simple example, right? So this is fine. Now we have successfully discussed the algorithm choice. Let's move on with the this one, concurrency and the data model. Yeah, so first let's go with the data model. Documents are stored in the dict as discussed, right? So see here, document ID, nothing but next, it is nothing but the content, the input, right? So this is fine. Index stored as, it is in this format actually, word set of document IDs, set of document IDs. Yep. So this is fine, I believe. So this is it for the data model. Let's move on with the concurrency part. So we will be going with a single threaded. We'll be making use of the pure Python dictionary. Pure Python dictionary. Fine. This is fine, I believe. Next, it can be later extended with a locks or async for the multi-threaded updates. For now, we are going with a single-threaded, and it can be later extended with the locks or async for the multi-threaded update. So this is fine, I believe. The next one, let's move on with a UML diagram, right? So let's move on with a UML diagram here. So based on what we have discussed, I have designed an UML diagram. So this has to work actually. Let's see the base class or the main class. We will be going with only one class. That's the base class or the main class, nothing but the search indexer. Search indexer, right? So it consists of the parameters. One is documents, another one is index documents, which is of the type dict, and index, which is of the type dict as well. Yep. So we will be going with only three methods. One is add document, and another one is build index, and search method. Yeah, these are some of the methods that we'll be making use of, right? So within the class base class search indexer, and we'll be going with the two parameters. One is document and another one is index. So based on what we have discussed, I have designed an UML diagram, right? So just pause the video and have a look into it. The exact same thing will be using for the code actually. So for the coding part itself, we have designed an UML diagram, right? So we have uh, I mean, I went with this actually. So this will be the so we will be adding the logic to the methods actually. We'll be making use of same parameters, same this one, same methods actually, same method, same parameters, as well as the same class. Nothing but the base class search indexer here or the main class, right? So all we have to do is we have to add the logic accordingly. Yep. So now, as we have discussed the UML diagram in the main parts, algorithm, this one, algorithm choice, as well as the concurrency and the data model, we are good to write the code. Let's start writing the code. First, let me import the RE actually, right? So this is fine. And also, we need the default dict, right? So I'll just go with from from collections actually. Yep. Let me import default dict actually. So this is fine. So first, what class will be making use of actually the base class search indexer, right? Search indexer. So this is fine. So within the search indexer class, let me do one thing. First, let's go with the initialization part. Yeah, as usual. Yep. So first thing, let me go with the documents actually here. Sorry, this has to be self. Yep. Let me go with the documents. So let me initialize this one to the dictionary as discussed. Yeah. Now let's go with the inverted index, nothing but word to the set of document IDs. We had discussed this one. I'll just go with here index. Let me initialize this one to the default dict of set. Right. Let me pass the set here. Yep. Yeah. Now first let's go with the this one first method actually nothing but the add document, right? Accordingly with the UML diagram. So I'll just go with add document. So this is fine. Add document, within the add document along with the self, I need doc ID as well, which is of the type int actually. Yeah, sure. Next, I need the content as well, which is of the type string actually. Yep. So this is fine. So within the add document first, we should be able to add the document content into the memory, right? So how can I articulate that one in the form of code? I'll just go with the documents here. Yeah, this has to show. Yep. Let me pass the doc ID as well. Yep. So let me assign this one to the content. So this is it. Simple one. Yeah. So next, let me do one thing. Let's move on with the second method, build index, right? Accordingly with the UML diagram. So I'll just go with here, build index. Yep. So this is fine. Mm, so within the build index method, so what we'll be doing actually, basically we'll be tokenizing and building the inverted index, right? So let's move on with the iteration part, or let's move on with the for loop directly. I'll just go with for document ID. This is not showing. Let me type this one, doc ID. So I'll just go with text in document actually. Let me go with the document. Sorry. Um, Let me go with document dot items. Yeah, so this is fine. So within the for loop, let me do one thing. I'll just initialize, or let me assign words to. We have imported re. I'll just go with re dot, yeah, find all. So let me go with here, uh, this one, regex actually. I'll just go with here R, 1 second, slash, let me go with W plus. Yep. So along with this, let me go with the text dot lower. So this has to show, this is not showing. Anyways, let me type this one entirely. Yep. So next, let me go with one more for loop here for individual word in words actually. Yep. So we are considering individual word and words. So let me go with index of word, index of word. Let me pass the word here. Let me add this one, document ID, to the index of the word. So this works actually, right? So add what, document ID. So I'll just go with a doc ID. Yep. So this is fine. We are done with the build index method. Next, we are left with only one method named search actually. I'll just go with def search, right? So def search. So let me go with self. Along with the self, I need parameter keyword actually, which is of the type string. Yep. So this is fine. Within the search method, what we'll be doing, we have to return the document IDs containing the keyword, right? So first, let me assign keyword to the this one, keyword dot lower. So I'll just go with this one, lower. This has to show. Yep. Next, we have to return the document IDs containing the keyword, right? So I'll just go with a return here list of index. So I'll just make use of the get here. What we need to get, the this one keyword actually. Else, if not found, then we'll be going with a empty list. Yep. So this is fine, I believe. So this is it for the coding part. Simple one, very simple one, right? So we are done with the coding part. So next, let's go with the example usage or the demo usage. Usually I get the example usage or the demo usage from the Google. Just give me a second here. So let me paste this one over here. So this is fine, I believe. Yeah, we are just calling the search indexer main class here. This one, see, main class. So we are just calling the add document method here. We are just adding the documents, right? So the cat sat on the mat, the dog chased the cat, the bird sang sweetly. So these are the IDs actually, document IDs 1, 2, and 3 respectively. Then we are calling the build index here. So this is fine. Then we are just printing for the interactive purpose result actually. So what is the output that we need to get when we run the code actually? Let's discuss the same actually. What's the output that we need to get here when we run the code? See, search results for the cat has to be search results for the cat, only cat. So this one we are going with the search results for the cat, right? Search results for the cat has to be 1, 2, 1, 2, because cat is present in document 1 and 2. Cat is present in the document 1 and 2, right? See here, the dog chased the cat sat on the mat. So document is present in 1 and 2. Search results for the cat, this one, search results for the cat 1 and 2 we have to get for the first one, right? So next we are going with the search results for dog actually. A dog is present only in the 2 actually, document 2, right? Dog in document 2 only. We have to get the output. Dog in document 2 only, right? So the third one, search results for the bird. Bird is in the third document only, right? So same thing, bird in document 3 only, meaning the output that we need to get here, search results for bird 3, right? So 3. Search results for the cat, document 1, 2. Search results for the dog, 2. Search results for the bird, 3. Then we are going with the search results for the lion. Lion is not present at all, man. So what we have to get, we are printing no document found in that case, right? No document found. So we have to get the output, this one, empty. So we are setting empty this one, this line. Look at the last line actually. So we are going with a list of self.index.get of keyword. If it is not found, then we are printing the empty list. So we have to get the empty one. So this is the output that we need to get. First, 1, 2 for the cat. It is present in document 1 and 2. So 1, 2 for the cat actually. No, for the dog, it's present only in the document 2. So we have to get output 2. For the bird, we have to get the output 3. Yes, we are getting the output 3. It is present in the document 3. And lion, we are searching for the lion, which is not present at all. So we have to get the empty list. Right. So this is fine, I believe. So let me delete this one entirely. So yep, now as we have discussed the written code, And as we have discussed the output part, let me run the code. So I'll just give Control J here, your screen. Let me enlarge this one. Just give me a second here. 1 second. This is fine. Let's see this one as well. Example part or the demo usage. I'll just go with the Python followed by the file name dot py. Yeah, search results for the cat. It is present in document 1 and 2. See here, document 1, document 2. Yep. So search result for the dog, 2 we are getting that is that output. So dog is present only in the document 2, right? So these are the documents we are considering, right? So here dog is present only in the document 2. Search result for the bird, it is present only in the document 3. We are getting correctly, and we are searching for the lion. See here, search results for lion, s dot search. We are calling the search method here of lion. Lion is not present in that case. We have written the code here, last line. So return list of self.index dot get keyword. If the word is not present, then we are going with a empty list. Actually, we are getting the empty list as output. We are getting the absolute correct output, or we are getting the desired output, right? So we have successfully this one written the code, and we have successfully discussed the output part as well, right? So now let's do one thing. Let's quickly discuss the limitations for the code that we have written. Yeah. So yeah, first let's go with the limitations of the current code. First one here, we are not going with any ranking or scoring, right? So no ranking or scoring, right? So no ranking or scoring. We are not making use of TF IDF here of the results hit. So this is one of the limitations actually. Yep. Next, no phrase or fuzzy search support actually. We are not going with this one phrase or the fuzzy search support, right? So this is also one of the limitation. Case insensitive but lacks stemming or this one lemmatization. Yeah, so case insensitive but lacks stemming or lemmatization. This is also one of the limitations. The final one is index is in memory, not persistent, meaning we are not going with any external database, right? So these are some of the limitations that I wanted to discuss with you guys. Yep, accordingly with what we have written coding part actually. Yep. Next, let's move on with the alternative algorithms and the trade-off. So first thing, we can just go with a try-based indexing, right? So try-based index. So what's the advantage or the pros here? So first thing, faster prefix search. Quite obviously, if you know the try, all go. So uh, basically, it will be faster, right? Faster prefix search actually, but more memory overhead. The trade-off is more memory overhead. So we can just go with the TF or IDF or the cosine similarity algo as well, right? So we will get the ranked results, right? But the main trade-off here is this one, higher computation or the calculation and the storage. That also we have to keep in mind. And the final one here is text, full text search libraries. So we can just go with the libraries like Oosh, Elasticsearch, right? So we can do that, but it is completely scalable and concurrent, no doubt. Yeah, it's completely scalable and concurrent, no doubt. But the setup is complex, and we have to think about the external dependencies as well. Yeah, so these are some of the alternative algorithms along with the trade-offs, right? So the future scope, we can just add the ranking model TF or IDF. So that is one of the famous ranking models. We can add that, and we can add the concurrency as well. Yep. Threaded indexing. I'm speaking of the threaded indexing. That also we can do. The final one is um, mm, we can just support the partial or semantic matching as well. Yeah, partial or semantic matching. Yeah. So these are some of the things that I wanted to discuss. Now we have successfully designed this one, a search indexer, right? Now, next what we will be doing, we will be designing this one, authentication system, right? I hope whatever we have discussed is completely clear along with the coding part, right? Coding part and the UML diagram. For now, this is it. Thanks for watching, guys.